Hello, this is Jenna from the Learning Center, and I'm going to be doing another video on use substitution, but here we're going to have a special case where we will be getting ln as one of our answers, or the natural log. So here I have an integral of 3x divided by 1 plus 2x squared, and this is a classic use substitution problem because we have two functions that are being divided and we can't simplify them. So we want to use u substitution to solve. So here we can set u as 1 plus 2x squared. And the reason we do this is we want to make this easier to solve. And we want to always pick the function that will give us a derivative of the other function. And to show this to you, you'll get du dx, which means you're taking the derivative of u with respect to x, and you'll get 4x. Now if you notice here, you have an x here and an x up here. So that shows that we have the correct u value because this x is going to cancel out with our other one. So now we want to solve for dx, so we can plug this in here, and we'll get du over 4x. And now we get a function of 3x divided by u times du over 4x. And we can cancel out these x values, and we're left with, I'm going to pull the 3 over 4 out front, times 1 over u du. And we know that this is the correct formula because we have everything in terms of u and there's not a single x value in our problem. So now when we solve this, we can pull the 3/4 out front because it's a constant, so we don't need it. Now if you notice here, we have 1 over u. Now does anyone remember what this is the derivative of? If you don't know, this is the derivative of ln. So I want to quickly draw a graph of ln, just a rough sketch. This is your function of ln, and where this is 1, and then we have our x. Now the reason I drew this graph is because a lot of people would want to just do ln of u, but that's not correct, because if you notice in our graph, sorry, just 1 second, takes forever to scroll back up. Okay, if you notice in our graph, the function does not go past 0. That means that our x value cannot be negative. So for that reason, we want to make this the absolute value of u, because that means it will always be positive. So now we're not completely done. We have to plug in our x value, or our function of u, which is 1 plus 2x squared. Oh, and we can't forget our c, because this is an indefinite integral. And that will be our final answer. So now let's consider this where we actually have a definite integral and we have bounds. So I'm going to go back to the top, and I'm going to set up bounds of 0 and 1. Now the difference between this integral and the last one is that the last one was just simply finding an antiderivative, and in this integral we're actually trying to find an area because we have bounds. So the only difference between this one and the last one is now we're going to plug in 1 and 0. So we notice that if you do this method, the c's are not going to matter because they're going to cancel out. So I'm going to start by plugging in our values. So we'll start with 1, because remember, our formula is f of b minus f of a, and this is our b, and this is a. So plugging in our values, we have 3/4 times ln of 1 plus 2, 1 squared, minus 3/4 times ln of 1 plus 0. Now when we simplify this, we should get an answer of 3/4 ln of 3, remember to make the absolute value, minus 3/4 times ln of 1. And actually, ln of 1 becomes 0, because if you look at our graph, 0 is the or 1 is the x-intercept for the ln function. So our answer is 3/4 times ln of 3. And that's how you would find the area using this method.